right, this is Vectors Day 2. Today's objective is to figure out the direction angle and again the component form of the vector. So we have different kinds of vectors. We could have a velocity vector that deals with speed. We also could have a force vector, meaning it's pulling or pushing an object. So to figure out the actual components of vectors, depending on how it's given, we're going to be using this formula right here. So we're going to be finding A by taking the magnitude and multiplying it by the cosine of the angle that it makes. And we're going to be finding the B part of the component vector by taking the magnitude and multiplying by the sine theta. So if you take a look over here at this unit circle here, this picture, we have some vector that they're going to give us, x comma y, right? We know that the x part on the unit circle always represents cosine. The y always represents sine. So when we figure these things out, we're going to be using cosine and sine for the angle. To figure out the actual angle, we're going to be using this formula here. Inverse tangent, that says. Inverse tangent. Inverse to the -1. That's a special button on the calculator that I'm going to show you. All right, so let's first practice finding the direction angle. So the formula was tangent to the -1 of B over A. So remember, this is the A, AI, and the B, J. So for number 1, I'm doing tangent to the -1. The B is -4, and the A is 3. So on your calculator over here, I have it. Please make sure that your mode, the mode here, this mode button, when you press it, that it's in degree mode first. Once it's in degree mode, you exit out. You're going to be looking above this tangent button. There's the tangent to the -1. How do I get that? I'm going to be pressing second tangent. And that's how I'm going to be getting this, tangent to the -1. And I'm going to be plugging in -4 over 3. So for some reason, I forgot the negative when I did this and did the little copy of the photo. So I'm going to put a negative right now. And when you press enter, you should get it to be -53 degrees. So that should be -53 degrees is the direction angle for that vector. For number 2, tangent to the -1. My B is 6, my A is 7. Plug that into the calculator, and I get it to be 40.6 degrees or 41 degrees. All right, so I'm going to be giving you different questions about this. I'm going to be asking you to find the vector whose magnitude is 5 and is in the direction of another vector that's -6, 8. So step by step, I'm going to tell you what to do. So the first thing we want to do is find the direction angle. So tangent to the -1. Remember, this is my A, this is my B. So 8 over -6. Go ahead and plug that in the calculator, and you also, again, get -53 degrees. To figure out number 2, which is finding A, go back to the previous slide. To find A, I'm doing cosine of the angle, and I'm multiplying it by the magnitude. I have the magnitude. The magnitude here is 5. The angle is -53 degrees. So I am plugging in cosine -53 times 5 in your calculator. Again, make sure your mode is degree mode. And you should get that A to be 3. Now I'm going on to number 3 to find B. I'm doing sine of the angle times the magnitude. So I'm doing sine of -53 degrees, multiplying it by the magnitude, which is 5. And I get that to be -4. So the component form for this vector, my A was 3, my B was -4. I could write it like this, or I could write it like this, 3i minus 4j. Either one is correct. All right, let's try another one. Find a vector whose magnitude is 12. There's the magnitude. and is in the direction of negative 9, 10. All right, so the direction angle number 1, tangent to the negative 1 of B, 10, A is negative 9. Again, plug it in the calculator. It comes out to negative 48 degrees. Finding A. A is doing cosine of the angle, timesing it by the magnitude. So it's cosine negative 48. And the magnitude here is 12. Again, you'll plug this in the calculator, and you get it to be 8 for A. To get B, I'm doing sine of the angle, timesing it by the magnitude. So it's the sine of negative 48, timesing it by the magnitude, which is 12 again, and I get that to be negative 9. So the component form of this vector is 8, negative 9, or you could write it as 8i minus 9j.